Assalamualaikum and good day, dear students. So let's discuss one example on force position methods. Exercise 2.8. The concentration of pollutant bacteria denoted by C in a lake decreases can be formulated as C equal to 75 exponent negative 1.5 t plus 20 exponent negative 0.075 t. Determine the time required for the bacterial concentration to be reduced to 15 using force position methods with an initial gases of lower time equal to 2.5 seconds and upper time equal to 5.5 seconds. Calculate until the approximate percent relative error less than 4%. Okay, so let's highlight the important information first. So you asked to determine the time required. Alright, means that we must to have the equation of Ft equal to 0 because we want to estimate or the value of our time when the concentration reduce to 15. Okay, so it means that this is the value for our C equal to 15. Alright, since we want to estimate for T, so we must have the two initial gas represent our time. Okay, so we have this information here. And then how many times we need to perform our calculation? So we must do check based on the given prescribed tolerance here. Okay, so let's discuss on the solution. So we have given concentration equal to 75 exponent power negative 1.5 times T and then plus 20 exponent power negative 0.075 times T. Okay, so in order to get the function of Ft, so we know that C is equal to 15. Alright, so now we have 15 equal to 75 exponent negative 1.5 t plus 20 times exponent negative 0.075 t. So in order to get Ft equal to 0, so I minus 15 both sides of this equation. Okay, so I will get Ft is given by 75 exponent power negative 1.5 t plus 20 exponent negative 0.075 t minus 15. Okay, because this is equal to 0. So now we have this as our function of Ft in order to estimate the time required for the bacterial concentration to be reduced to 15. Alright, so let's start our first iteration. Okay, So first iteration, so we have t, the starting value is bounded by this value 2.5 and also 5.5. So I omit the unit first, second. Okay. So now we calculate if TL equal to 2.5, then FTL equal to F2.5. So you substitute into your function, alright. So if you use your calculator, you should get this value. If I round off into 4 decimal places, 3.3444. Okay, then for TU, our time upper is 5.5. So calculate for the function. Okay, substitute into the function of ft. So by using your calculator, round off into 4 decimal places, you should get negative 1.7405. Okay, now we calculate the first roots estimation for our time, okay, by using force position methods. So by using force position formula, so let's calculate our TR. Okay, so TR equal to TU minus FTU times with TL minus TU divided with FT lower minus FT upper. Alright. So now we substitute the formula. So we have here is TU 5.5 and then minus. So FTU is negative 1.7405 and then multiply with 2.5 minus 5.5 and then over FTL is 3.3444 and then we minus with negative 1.7405. Okay, so if you use your calculator, you should get TR equal to 4.4731 second. Okay. So now we calculate for FTR. So F of 4.4731. So if you substitute into the formula, okay, so you will have 75 exponent negative 1.5 times with 4.4731 and then plus 20 exponent negative 0.075 times with 4.4731 and then minus 15. So by using your calculator, you should get negative 0.6087. Okay, so now we check. Since FTL multiply with FTR, okay, equal to, so remember our FTL is 3.3444, and then FTR is negative 0.6087. So this gives us, of course, negative, so less than 0. So we can say that the roots lies in the lower subinterval. Okay, then TU, we replace the value of TR, so now our TU become 4.4731 second, and approximate percent relative error we cannot calculate at the first iteration, so we just put dash. Okay, so now our T is located between or bounded by this new interval, alright, which is 2.5 and also 4.4731. Okay, now we continue second iteration by using the value of T now bounded by this interval 2.5 and also 4.4731. Okay, so now our TLs, T remain the same, and then F 2.5, okay, right here is FTL equal to F 2.5 and then equal to 3.3444. Okay, now our TU is equal to 4.4731, then FTU equal to the value of function when we substitute T with 4.4731, so we already calculate this, okay, which is equal to negative 0.6087. Right. Okay, so now we calculate our TR. Okay, so TR is equal to TU minus FTU times with TL minus TU over FTL minus FTU. Okay, so now we substitute the value. So here is a 4.4731 and then minus. So here we have negative 0.6087 multiply with TL minus with TU. So 2.5 minus 4.4731 and then divide with FTL 3.3444 minus FTU negative 0.6087. Okay, so if you use your calculator, you should get TR equal to 4.1693 in 4 decimal places. Okay, then we calculate the value of our FTR. Okay, so we insert the TR into our function. Then if you use your calculator, you should get FTR equal to 0.2264. Okay, so again we need to do the check the condition. Alright, so here if we check the condition, since we get FTL multiplied with FTR, okay, equal to 3.3444 multiplied with negative 0.2264, and this multiplication will give us negative value, means less than 0. Then again the roots lies in lower subinterval. Okay, means that then TU will replace the new of value of TR, which is 4.1693. Okay, okay, now we calculate our approximate percent relative error. So we have here is current approximation, okay, which is 4.1693. Alright, and then minus with previous approximation 4.4731 divide with 4.1693, and then multiply with 100, and then put the percentage, we should get 7.29%. Okay, so since this value is greater than our stopping criterion, then we need to continue the next iteration. Okay, so for third iteration, we can summarize in this table here. Okay, so third iterations, TL remain the same, so 2.5. TU replace the value of your TR. Okay, means that this value we bring here. Alright, so now we have 4.4731, and then FTL remain the same, 3.3444, and then for FTU, now we use this value here. Alright, which is negative 0.2264. Okay, so if you calculate your TR here, okay, using force position method formula, so you should get TR equal to 4.0635, and then the FTR is negative 0.0850. Okay, so you can calculate and try to check with my solution. So therefore FTL multiply with FTR, so we have here positive, negative, so this is also negative, less than 0. Down we calculate the approximate percent relative error, then you should get 2.60. Alright, so remember our stopping criterion is 4%, Okay, so therefore this value here, approximate percent relative error less than the stopping criterion. Okay, hence we can stop the computation process. Alright, so we can make a conclusion. Okay, therefore the approximate time required is t equal to, okay, so this is our TR after 3 iteration, t equal to 4.0635 second, with the approximate percent relative error equal to 2.60%, which is less than the given stopping criterion 4.0%. Okay, so this is our solution. Alright, that's all I think. You may try other exercises. If you face any difficulties, do not hesitate to communicate with your lecturer. Good luck.